YouTube channel. As we know that we are continuing the Geek for Geeks 160-day challenge series. So today is day 6 and the problem is majority element and the difficulty level is medium. Okay, so let's read the first problem. We have given an array of integers array where each number represents a ode to a candidate. Return the array that have odes greater than one third of the total odes. If there is not a majority ode, we have to return an empty array. And there is a note also. The answer should be returned in an increasing format. So at most we will have a two elements that have majority element. If not, we will return an empty. So we can see, for example, we have array 2 1 5 5 5 6 6 6 and 6. So output we will get the 5 and 6. Okay, because 5 and 6 occur more than the n by 3 times. And we have a second array 1 2 3 4 5, and there is a no majority element because every element is occurring just once, so we will return an empty array. So let's break down the problem. Okay, so I'm going to explain on board. We will take a array, that the same array 2 1 5 is I think 4 times and 6 is 5 times. Okay, let's take 2 1 5 is 4 times and 6 is 5 times. Okay, all right. So we have a given array and we have to find those elements which is occurring more than n by 3 times, right? So at most two element we have to find, at most two elements. That means these candidates are taking as a oath, so maybe candidate 1 and candidate 2, and these candidate counts as a majority elements when we have the occurrence of these two numbers n by 3 times, right? Okay, so let's understand the problem, how we are going to approach this problem. Okay, so a candidate has votes greater than one third of the total votes if their count is more than n by 3, right? In the array there can be at most two candidates only, so this is the conditions which should be satisfied. And the idea is use a voting algorithm to identify up to potential candidates that could have a votes greater than length of array. So there is a algorithm that name is Boyer-Murray algorithm. Let me take the another pen. Boyer-Murray algorithm. Okay, that Boyer-Murray algorithm is whatever the we have a candidate. If candidate have a majority votes, then majority votes, so the number of votes should be at least greater than n by 2. Okay, so this problem is based on this algorithm. This is basically uh, this problem is advance of the Bayer-Murray algorithm. Okay, now we follow the steps which we have to take care. So we solve this problem in two phase. Okay, the first phase will be like find that potential candidates. Like we will find later the number of candidate, the majority candidates. That means we will count the number of the candidate. Okay, but first we need to find the potential candidate. What is the potential candidate? How can we find? So there is a condition, three condition basically. So what are that these conditions? So use two count, we will use the two counters and two candidates also. Okay, because at least we have to find the at most two elements. So can maybe candidate 1 and candidate 2, and as well as their count 1 and count 2. Okay, so we will traverse the array and update the counters as candidates based on the some rules. Okay, so what are the rules? Let me rub it, because we already written like candidate 1, candidate 2, and we will count this. Okay, let's first let me write down the conditions. If the current element, first we will apply the traversing here. So if the current element matches one of the candidate, so we will count increase the counter. It will match, so we will increase the counter. Okay, so if neither counter is active, that means if it will zero, so we will assign the current element. Don't worry guys, I will explain while taking this example. Assign the current element as a new candidate, because suppose we are taking the first element 2. Okay, if 2 will match this candidate or this candidate, okay, so we will the increase the counter. What are the counter? We can consider count 1 and count 2, 0 comma 0. So we can initialize counter 1 and counter 2 with 0 0. Okay, so let's take example. If candidate 1 is 2, okay, if the candidate is 2, it if it match, we will increase the counter. Okay, so if the counter is equal to 0 0, then we will assign that current element as a new candidate, as new candidate. Okay, so in case of candidate 2, we'll do the same. And third condition is, I will rub this here and take the pen. See, third condition is if the current element does not match either the candidate or the counter. So okay, so we will decrement the both counters. Decrement both counters. That means count 1 and count 2. Okay, so these are the steps. First is the, we will find the that potential candidate. That means we will check if current element match the with the current candidate, we will increase the counter. Okay, if counter is active, that means if counter is equal to 0, we will assign the current element as a new candidate. Okay, so third condition is if the current element does not match with the candidate also and not the counter, so we will decrement the counter. Okay, this is the first phase. Now phase 2. So we got our candidate 1 and candidate. Now we will count the count the like how many times candidate 1 and candidate occurs. Okay, so we will find the count 1, counter 1 and counter 2. Okay, we will count. We have to find the counter 1 and counter 2 occurrence. Okay, occurrence of the candidate 1 and candidate 2. So now we will got the counter and as well as the candidate also. So we can take an array and we can store these two elements, and if the candidate 1 is greater than candidate 2, then we will do the swipe. Basically we will arrange the in increasing order. Okay, so this is the explanation of the solution. Now let's implement in the code. Okay, so first we will traverse on first we will initialize the candidate 1, candidate 2, and as well the counter also. Okay, so candidate 1 and candidate 2, we can consider it for initializations -1, -1. Okay, and we will take the counter 1. We can consider count 1, and count 2 is equal to, we can consider like 0. We can initialize with 0 0. Okay, now we will traverse the array. For I, we can take the num for num in array. Sorry guys. if num if num is equal to candidate 1, if that number is equal to candidate 1, then we will increase the counter. Okay, counter for which candidate? So counter will be count 1. Count 1 we will increase by 1. Okay, like this. Elif, we have another concept. If num is equal to candidate 2 as well, candidate 2, so we will increase the counter. In case of candidate 2, we have a count 2 and we will increase by 1. Okay, so this is the first case. Now we will implement the second case. Second case is like, we if the counter is equal to 0, then we will assign we will assign the element as a new candidate. Okay, so elif count 1 is equal to 0, then we will assign the candidate 1 is equal to that number. Okay, and we will increase the count as well. Count 1 is equal to 1. Okay, so elif for the counter 2 also as well. So count 2 is equal to 0, then we will assign the candidate 2 as a new candidate. Candidate 2 is equal to, we will assign the num. Third case is, if both are not matches, then else we will decrease the counter. Count 1 equal to 1, and as well count 2 also. Okay, so this is the first case. Now we have candidate 1 and candidate 2 element. Okay, now we are going to in second phase. So first we have to find the our length for comparing like n by 3, that measure for finding the majority element. So what will the our length of array will be 1, and we can take an empty array or result empty array, and then again we will check if candidate, sorry, for candidate in our candidate 1 and candidate 2, right? Candidate 1 and candidate 2, we will count the counter candidate 1 and candidate 2 array. We can use our count function here for finding the count occurrence of the candidate, and the condition is should be greater than n by 3, right? Should be greater than n by 3. So result will append in our result, that candidate will append our result candidate, right? Now we have candidate 1 and candidate 2. Now we already count the occurrence of the candidate 1 and candidate 2 as well, and we store in our result also. So in the last there is that note answer should be returned in increasing format, so we have to take care of that one. So we have to return sorted result. Okay, let's check, compile and run. Name array is not defined. Oh, okay. That array where I took array. Okay. Uh, We have to return that result, right? Sorry, guys. Expected output is 5 6, and my output is empty array. Why? Let's check. That condition we are counting for two candidate, one candidate two, count one is equal to 0, then candidate one is equal to with a sign, and okay, we will increase this as well as this one also, count 2 equal to 1 we will increase, and if the both conditions will not satisfy, then we will decrease the counter, and this okay, let's check. Still I'm getting an empty array. Okay, I got it. What I'm making the mistake, basically we did it right, that, and we have to return this. Now let's compile. Yeah, so we got the output as expected output, right? Let's submit the code. Yeah, so all the test cases are passed and it is successfully run also. Okay, I'm going to revise once more for the what are the rules for finding the majority element. So basically, we have to consider two candidates, array 1 and array 2, and their counting of the votes also. So for initializations, I have taken two variables, count 1 and count 2, and that variables are initialized with 0 0, right? Okay. So what for finding the majority element, basically how can we apply the Boyers-Mori law here? So the algorithm is like, we have to find these candidates, like which candidates are majority, right? Then we will count the occurrence of that candidates. Okay, if that candidates occurrence of that candidates is greater than n by 3, then we have the get the output. Okay, so what are the rules? If the first rule is for finding that candidate, if the current element matches with the whatever we considered the candidate, so we will increase our counter. Okay, as you can see, like we have an array for 2. If 2 we initialize candidate 1 is -1. If 2 is equal to -1, okay, 2 is equal to -1, so we will increase the counter. Okay, but this is no, this will not satisfy because 2 is not equal to -1. Okay, so what is the other condition? Other condition is if counter is equal to 0, then we will assign the new candidate that uh, we will for that element, so we will assign the new candidate. Okay, and we will increase the counter also. But here counter is count 1 is equal to 0, then we will increase that, like 2 is equal to 1. Okay, so I'm going to explain again, uh, taking these examples. So initialization is like candidate 1 and candidate 2 is -1, and counter 1 counter 2 is equal to 0. So first iteration is the, like for that number is equal to 2. Okay, so our counter is 0, then candidate 1 will be 2 and counter will be 1, right? For iteration 2 we have a num 1, right? We have a num 1, and count 2 is equal to 0, then candidate 2 will be 1 and counter will be 1, right? That is the clear, like this is the new element, and this the occurrence of the 2 is also 1. This is also the new element, and the occurrence of the 1 is also 1. Okay, fine. Now number let's take the number 5. Okay, so 5 is a new element here, then we will occurrence of the 5 is 1 here first. Then again we will check if counter is greater, like counter is equal to 0, and like that number is also same, then we will increase the counter as well. So 5 for 5, the count is 1 2 3 4. Okay, so counter will be 5 and candidate is 5 for candidate 1. Now let's jump to the 6. 6 is the new element, then we will assign the candidate 2, and 6 occurs 5 times. So counter is the 5 times and candidate is 6. So we got the counter and as well as the candidate also. So candidate 1 is 5 and the occurrence is 4, and candidate 2 is 6 and occurrence is 6 times, right? So like this we approach, like we have occurrence now, we have a candidate now, and now we will find the length of the array, and then we will divide by 3 if counter is greater than that n by 3, then these elements are the most occurring elements, and these are the majority elements of the array, like this. Okay, so this is the medium level problem and the little complex also. So first try to understand what's the Boyer-Mori law and this algorithm, what are the steps to follow we need to. If my video there is a confusion, so please rewatch this video, and I hope you will understand the problem also and as well as the solutions also. So yeah, uh, for today that's it, and now we will continue the series for day 7 tomorrow, and I will see you in the next video. Thank you guys, bye bye.